All right.
That's are funny. Well, I blew that one, didn't I?
Thank you. You ready to go now? All right. We're on section 7.2, page 353. We're talking about the graphing polynomial functions. You looked at the end behavior of polynomials. What we found out is when it's even, the arrows are either going up or down. If it's positive, if we have a leading coefficient that's positive, the arrows are going up. If we have a leading coefficient that's negative, it's going down. Correct?
Yes.
And with the odd highest degree, the arrows are opposite, right? And so if my arrows are like this, is the leading coefficient positive or negative?
Negative.
Negative. And if it's like this?
Positive.
Positive. Okay. So you need to know that. But it also helps you on this particular section. And this is a rough section because this is about graphing, okay? You have to kind of understand where we're at in terms of graphing. So you'll need a piece of graph paper to do the notes. You'll need probably one, I think, do all of you have a blank one?
No.
I have one. Okay. Okay. So you'll need one to kind of take notes and get an idea of what to do, and then you'll need one for grade, for the assignment. Okay, so when we look at graphing, it'll say something like this. Graph f of x equals x to the fourth plus x to the third minus 4x squared minus 4x. Okay? The first thing that we need to look at is what we learned from the last section, was that this is, the arrows are either going the same direction up or they're down. Which is it, up or down? Up.
Up. This one, both arrows are going up. So when we graph this, we're going to have both arrows going up. All right? And most likely, how many places are we going to touch the x-axis?
2.
4, isn't it? 4. Most likely, not always. I mean, there are cases, but if there are 4, if it's to the 4th power, there are usually 4 roots. Now, it's possible that 2 of the roots could be complex or imaginary, correct?
Yeah.
But in this case, we don't know that for sure. We'll look at it and see what happens. Okay, so let's talk about y values if we cross the x-axis. If we cross the x-axis, what's the y value on one side?
Positive.
And the y value on the other?
Negative.
You won't know exactly where we cross those, okay? We'll list them in between. Do you remember when we did that? In between this or that? But you know that you've crossed it's crossed the x-axis. I think I said the y-axis. You know you crossed the x-axis when one y value is negative and the other is positive, or vice versa. You
I think
understand?
you're good. I think you said X.
Okay, good. I hope so. All right, so let's take a look here. We're going to do an x, y. You need to be very accurate on these. You will find a place where they go to infinity, and you'll start to see that. So we're just going to go around the room, and I'm going to assign you a number to plug in for x. Now, when we plug into the 4th root a negative number, remember it turns into positive, right? If it has a even exponent, right? So if I plug a negative number in there, we're going to get a positive value back. So you'll need your calculators. We'll start over there with Brandy. We'll start with a -3, and Kaylin a -2, Carson -1, and Josh 0, and Dalton 1. Is that your phone?
Yeah.
Yeah. Can I have it, please? Okay. You gonna shut it off, please? Sure. Come grab it before you go to wrestling practice.
Okay.
Please. I don't want you to be without it. When you're on the bus.
Okay, yeah, takes too long to now. Just turn the springer off.
Okay, good. Thank you. All right. Carson, they'll just be sitting here, so if I have not be in here,
Yep.
just grab it. All right.
You said I'm -1, right?
Yep, you're -1. No. Yes, because Josh, what were you? 0, and you were 1. Okay.
plug it in at the
Where do
calculator?
you plug it in at?
Well, X. But
X, yep.
What?
Here, 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 and there.
Why do we need a calculator for this?
You don't, you won't,
Oh.
but they will,
Okay.
okay?
Okay.
I think you can do yours in your head, can't you?
Yeah.
I think so. If I'm looking at 1 plus 1 is 2, minus 4 is a negative 2, minus 4 is, minus what?
I said, well,
Okay,
negative.
okay. All right, you got it.
Okay.
Brandon, you got negative 3 yet?
One second.
Okay, Caleb, negative 2.
0.
0, okay, so we know we touched there, right? Josh,
I got 0.
you got 0, yours is 0. What about negative 1, Carson?
0.
We can't all get a 0.
I got 30.
Well, good. Let's see here. Negative 1, we have 1 plus a negative 1, minus 4, plus 4. That's 0. And a negative 2 is 0?
Yep.
And what was 1?
It's negative 6.
Negative 6. Okay. I can't believe it. Okay, we got that many zeros in that spot. Okay, let's try to graph it. Negative 330.
Just one.
Negative 330. It's way out there. I can't even graph it, right? Actually, I think that probably would have showed it because of my wide lens. It doesn't show it in the thing, but you can put it back. So put the left edge about right here, and I think I'll be on there. But thanks anyway.
Okay.
Okay. It doesn't show up the same on the video. I hope. She yells at me. I'll say, "Well, Kaylin turned it, and I made her turn it back." So negative 330, negative 2 0. Then we have a negative 1 0. 0 0. And 1 and negative 6. Okay. We're kind of missing the spot, aren't we? Okay. Where do you think the next spot would touch? Would it touch over here, do you think? Or over here? Okay,
I think over,
to the right. You're
Yeah.
gonna tell me why.
because, well, A is positive.
Yes, and it's in behavior, they both gotta be going up, right? We know this one's going up, right, because of negative 330? So this one comes from here, and then it comes, and how far down do you think it goes? Well, you could put a half in, but it doesn't go very far, does it? Okay? Can somebody put 0.5 in, or negative 1.5 in? Well, can you
Here
do
it
that?
goes past the little 2 pi, little above, about 1. Goes past negative 1 a little bit. There, now you can see it.
I think it's in the chart, isn't it?
Yeah, it goes.
What do they get? Look at the chart there.
Negative 1.3.
Negative 1.3, so it comes down here about right there. And then it comes back up, right? How far up does it go? Look at negative 0.5,
0.9.
0.9, so it doesn't even make 1, right? And then it comes back down, and then it comes down, doesn't it? Now, what Dalton says is, whoops, I missed my spot here. What Dalton says is it's gotta go back up. Why?
Because it's even.
It's even and it's positive, so it's gotta go back up. So let's put in 2 and see if that'll do it.
That'd be 0.
2 is 0, so there's where it touches, right there. Okay? And it does this. The marker's not real strong, but that's what it looks like. That is what we get when we get a sketch. Now, how difficult it is? Well, you gotta find points in between sometimes, right?
Yeah.
Now, if you look at the bottom of the page, there's the words location principle in yellow, right? Okay? 2 sentences up, it says, since zeros of the function are located at x-intercept, there is a 0 between each pair of these x values. This problem for locating zeros is called the location principle. The location principle is what I said before. If there's a value above the x-axis and a value below the x-axis, it has to touch the x-axis somewhere between those two values. Right? That makes sense, doesn't it?
Mm-hmm.
Okay, all right, so, let's talk about some of the points here, all right? First of all, these go on forever, right? All right, so, they are not, they go on, we don't know what those values are, they continue to go on forever. But I wanna show you something. This point right here, and this point right here, and this point right here, they have some meaning to us. Alright? This point right here was, what we'd say, a negative 1.5, I'll write them over here. Why don't I write them over here? A negative 1.5, and then we said a negative 1.3 approximately, right? And then we have a negative 0.5 and 0.9, right?
Yep.
And then that bottom one, it looks like it's somewhere in between, let's say is it 1.5
Negative 6.6.
and a negative 6.6? Okay, these are 3 points. They have a certain meaning to us, okay? The first one is called what we call a relative or local minimum. Okay? It's a relative or a local minimum. It means that its values are low for the area around it. If you take a look here, these values, this is the lowest point compared to the values around it. Do you see that? What do you think this point is called?
Local
Local
maximum.
maximum. This is called a relative, and I will use both terms interchangeably, or local maximum. It means that it's higher than the points around it, but it's not the highest point. You understand what I'm saying? But this guy right here happens to be the absolute minimum, which means that it is the lowest point of the graph, bar none. Now, is it possible to have an absolute maximum?
Yes.
Yes, it is. We do not have one in this case because both graphs go on forever. You understand that? Okay. These are called extreme values. In calculus, you learn how to use a derivative to find critical points. They're called critical points, and they change the graph. All right. Right now, we're going to use our calculator to find them. Okay. So turn to the assignment on page 356. Page 356. So this is exercises 13 through 26. Complete each of the following. A, graph each using a table. B, determine consecutive values of x between each real zero is located. Did we have to do that here? Did we have to come up with the x values, the two that it's between where it touched the x-axis? Why? Why didn't we have to give the two integers that the graph went in between?
Because there was
Didn't it touch it on integers? Touched the x-axis on integers, so we didn't have to give an in-between, did we?
Oh, yeah.
Sure, right?
Yeah.
Okay. We had to do that on the parabola, remember on that test?
Yeah.
And then C, estimate the x coordinates. It says estimate the x coordinates. Does it say the y coordinates? So you're only going to estimate these. You're not going to estimate those. Estimate the x coordinates at which the relative maximum and relative minimum occur. Okay? I got you going to 13 through 20. Let's do 20 together, shall we?
When it says estimate,
Estimate?
yeah, sorry.
Uh-huh.
Is that like the nearest whole or nearest half?
You need to be a little bit closer than that. I would say, maybe x.6, or I'd say to the nearest 10. I mean, like 5.6 or whatever, okay? So let's do number 20. Would you read it to me, please? Caleb?
f of x equals x to the fourth minus 10x squared plus 9.
Okay, so I usually start with the -3 to 3 and see how I do. Okay, let's reverse it. You got a -3 this time. Josh, you got a -2. Carson, you got a -1. Kaylin, you got 0. And Brandon, you got 1. Brandy, what'd you get?
I got 0.
You got 0 for 1?
Yeah.
Okay, so you got 1 minus 10, -9, yep, okay. What we got 0 and what we get?
Oh, 0, 9.
9. And we put a -1 in, I bet we get the same as this, right?
-2, I got -15.
-15. And what about -3?
I got 0.
You got 0. Well, these are gonna come out too. Why do I keep picking the ones that come out even, right? Okay, once again, our graph should do this, shouldn't it? Okay?
Yep.
And I should have picked an x cubed or something, right? Kinda messed that up. And we have 4 roots. We got 3 of them shown, don't we? All right, let's take a look and graph it and see where we need to go. Okay? So we got a -3, 0, a -2, a -15. We're down here. -1, 0, oh my goodness, that pops up, doesn't it? It goes down and comes up real quick, doesn't it? And 0, 9. Right? And then back to 1, 0, so, okay.
Shoot, I didn't need enough blanks.
I'm thinking we should go this way, don't you think?
Yes.
It comes, I'm guessing it comes from there, goes all the way down here, comes up here, and then back.
20 is going to take up the page by itself.
I'm thinking it comes back up. What do you think? I don't know. 2 is 31, right? Did I do this right? I did 2. This is 16, right?
Yeah.
Minus 4 times, this is -40, right? Oh, it's negative, shouldn't it? I didn't do it right. Plus 9.
It'd be a -15 again.
It'd be a -15, okay. So, do you think it comes back up? Try 3. 3 is gonna be 0 too, isn't it? Because it's gotta be symmetric.
Yeah, it's 0.
Yeah. So it looks like we have the letter
W.
W.
Oh gosh.
Yeah. So here are roots, and we don't put consecutive integers again, do we? We put a -3, -1. Oh, we gotta go through this, all right? So this is A. What does B say? B says give the consecutive or the actual points, right? Well, let's give the actual points. It would be a -3, -1, 1, and 3, correct? And then C says list the x values where it has minima and maxima, right? Well, it looks like to me that this is at a -2, doesn't it? A -2, we wouldn't have to estimate, would we?
No.
The x value is -2. So C is a -2, and it looks like it's an absolute minimum, doesn't it? And then I'm guessing at 2 we have an absolute minimum. Do we have any max?
No,
No. Well,
no.
well, you have a relative.
It's a
Yes.
relative maxima and relative minimum.
It is a relative max. So we do have one at 0. This guy right here is a relative max. Why it's not an absolute is because these continue on forever. Right?
Do we have to put the absolute minimums?
I think it just, if you just put minimums, they'll give it to you. I think that's a great question, and I think the answer is just put minimums.
Okay.
I just kind of wanted to show you, okay? Okay, so your assignment for, oh goodness sakes, for Thursday,
For what?
Yeah.
page 356, numbers 13 through 20, is that right?
Yep.
I wonder if we couldn't get this done by tomorrow and go on.
So just absolute minimums we have to put?
No, you just either put this. All they do is to say identify maximum. The only reason I wanted to identify was to get you to understand more about absolute and about relative. So when is this due? I hate to have it due Thursday. You won't need tomorrow to work on it, will you? How much time do you have to work on it?
A little over 20 minutes.
Okay, let's see how you do. And then we'll decide.